Good day, guys. Today, I'm going to discuss some exercises on proving trigonometric identities. Prove the following identities by working on one side only. So let's start with this identity. Tangent theta, cosine theta is equal to sine theta. So let's have the proof. Since we're asked to prove this using one side only, better to work on the complicated side. So that is working on the left side. The left side is tangent theta, cosine theta. Okay? So we want to express this in terms of a single function, sine theta. So we know that tangent theta has an identity sine over cosine. So we have sine theta over cosine theta. Then times cosine theta. Okay? So from which we can cancel out cosine theta. So giving sine theta. So that's it. We're done. So tangent theta, cosine theta, we are able to express it in terms of a single function, sine theta. So let's have number 2. Let's say we have cotangent x times cosine x is equal to cosecant x minus sine x. To prove this working on one side only, so we have to decide which one is easier to work with. Actually, any of this side. If we choose the left side to work with, so we have to express that in terms of difference. If we're going to choose the right side, our goal is to what? To express it in terms of product. So let's try working on the left side. So our goal is to express it in terms of difference. Okay? So let's start working on cotangent and let's see what will happen. So from quotient identity, cotangent x is equal to cosine of x over sine x. Okay, guys? Then times cosine x. Now, multiplying cosine x with this cosine x, we get cosine squared x over sine x. So to be able to express this into two terms, so we have to express the numerator as what? As either a sum or difference. So we know that cosine squared is equal to 1 minus sine squared x from Pythagorean identities. Then over sine x. We can split this fraction into two fractions. So the first one is 1 over sine x. Then the second one is negative sine squared x over sine x. Okay? What comes next? So 1 over sine x is equal to what? It is equal to cosecant x, no? From its reciprocal identity. And then here, dividing sine squared x with sine x, or by sine x, we get what? Sine x. And this is already the right side. So we're done. So it means we have proven that the left side is equal to the right side. What about if we do the other way around? So let's see. Let's say we want to work with the right side this time. And we want the right side to be in terms of product. So this is our option proof, no? So let's get the right side. So that is cosecant x minus sine x. So again, our goal is to express this difference in terms of product. So meaning we have to combine these two terms into a single term. How to do that? So let's try working on cosecant x. From its reciprocal identity, that is equal to what? Equal to 1 over sine. So 1 over sine x, that is the identity for cosecant x. And then we copy this negative sine x. So let's combine these two terms in terms of a single term by combining these two, no? Getting the LCD. So the LCD is sine x. Sine x divided by sine x, that is equal to 1 times 1. So we have 1 minus sine x divided by 1, that is sine x times sine x, that is sine squared x. Okay, guys? What comes next? So this is now one term already, or that is just a single fraction. Looking at the numerator, this is what? What identity reminds you of 1 minus sine squared x? So that is from Pythagorean identities. So actually, that is from sine squared x plus cosine squared x is equal to 1. So we know that cosine squared x is equal to 1 minus sine squared x. So we write it as cosine squared x, then over sine x. Okay? Yeah. So since you want it to be cotangent x times cosine x, so let's split cosine squared x into what? Into cosine x times sine x. And then over sine x. So let me put here the other cosine. Okay. So then from here, we have cosine over sine x. Cosine x over sine x is what trigonometric function equal to this quotient. So, okay, from quotient identity, we have cotangent. So that is equal to cotangent x, then multiplied to cosine x. Well, that's it. So since we are able to express this difference in terms of cotangent x, cosine x, so we're done. So we have proven that the right is equal to the left, okay? And that makes it really an identity. Let us have another one. So this is number 3. We have 1 plus sine of beta over cosine beta. And this is equal to cosine beta over 1 minus sine beta. What about this one? So let's have the proof. So working on one side only, looking at the left side and the right side, actually they have the same level. No? So we can choose any of the two. So let's work on the left side. 1 plus sine beta over cosine beta. Okay? We want to express this in terms of a quotient also involving cosine and sine. So meaning we cannot do something about this, no? So we don't have that direct identity that will convert this into this form because this right side is already what in terms of cosine and sine. So let's see what we can do about this. On the right side, look at the right side. There is cosine beta, no? So if I want to have in the numerator cosine beta, so let's try multiplying the numerator by cosine beta because that is what we want. Okay? So let's multiply. We multiply the numerator by cosine beta, but I have a violation. If I'm going to multiply the numerator by cosine beta, I am changing the value of this original quotient, okay, or fraction. So what we do so that there will be no violation in algebra, I have to multiply also the denominator by cosine beta, right? So this is equal to 1. Of course, we assume that cosine beta will not have a beta that will make cosine beta equal to 0, okay? So that's what we assume. So cosine beta is non-zero, okay? So this is now equal to what? So let's multiply 1 plus sine beta multiply 2 cosine beta, and the denominator, I mean, is equal to what? Cosine is squared, right? Okay? Cosine is squared beta. So we have already cosine beta in the numerator, so we have to retain this. So this is what we're going to work with. This 1 plus sine beta all over cosine squared beta. So let's see what we can do here. So there is an identity for cosine squared beta involving sine, no? Or in terms of sine. So replacing that by that identity. So what's the identity for cosine squared beta? So that is 1 minus sine squared beta. Okay? From one of the Pythagorean identities. So copy the numerator. We have 1 plus sine beta. So be sure you're going to make cosine beta as is, no? Because that's what we need in the numerator. So this is already correct. Now, the denominator from your algebra can be factored into what? Into a plus b, a minus b form, because this takes the form of a squared minus b squared, right? So again, what is the factored form of a squared minus b squared form? So this is equal to a plus b, a minus b. Okay, so let's do that. So 1 plus sine beta multiplied by 1 minus sine beta. Okay, so we have in the numerator 1 plus sine beta cosine beta. Okay, so from here, so there is a common factor in the numerator and in the denominator. So we can cancel this out. So we are left with what? So the numerator now is equal to cosine beta And then the denominator is what? The denominator is 1 minus sine beta. Okay, guys? Well, let's check the right side. Is this equal now to the right side? Yes, so that's it. So we have proven that this is really an identity, okay? The left is equal to the right. Of course, you can do the same procedure working on the right side. Proving identities is not actually unique, no? The procedures. As long as you are replacing any expression with its equivalent and you do correct algebra, then and then arriving to your goal. So that's correct. No? Okay. So let's have the part one. We have, I think I will be needing much space for number 4. So number 4, we have tangent of theta minus sine of theta quantity squared plus 1 minus cosine theta quantity squared, and this is equal to 1 minus secant theta quantity squared. Okay? So let me erase this now so that we have much space. Okay, let's begin. Which one do you think is worth to work with? So definitely the left side, because it's more complicated, and a more complicated expression is easier to make it simple rather than the simple one, you're going to make it complicated. Okay, guys? So let's get the left side. Tangent theta minus sine theta quantity squared plus 1 minus cosine theta quantity squared. So again, our goal is to put this in the form of 1 minus secant theta quantity squared. Okay? So first, let's work on tangent theta. Since we have sine and cosine here, so let's express tangent in that same function as much as possible. No? Same with sine cosine involving sine cosine. So let's see what we can do about this. Okay. So from quotient identity for tangent, we have sine theta over cosine theta. Okay. And then minus, what about here? Copy. We just copy this. Quantity squared plus. Okay. And then we here. So let's have, let's copy for the meantime, because I don't see any relationship at this point in time with the first term. This involves cosine, and there is a quantity here involving cosine also. No? So let's isolate such, such 1 over cosine from sine theta. So how can we do that? So we factor out sine theta, okay, inside. So if we factor that out, I will get sine theta multiplied by, so what is the remaining in the first term inside? 1 over cosine, okay? 1 over cosine theta. Then here, negative 1. So we have 1 minus 1 over cosine theta, then minus 1. So everything is raised to 2. Then plus 1 minus cosine theta quantity squared. Okay? So are you now seeing a progress, guys? Um, because I want it to be secant in terms of secant, so let me express 1 over cosine in terms of secant, and at the same time, distribute this exponent to the exponent of its factor inside. So remember, in algebra, we have a times b raised to n. I can express this as a to the n, b to the n. Okay? So meaning, I can square sine. So we have sine squared theta multiplied 2. And then at the same time, I'm going to apply an identity here. This is secant. Okay? The reciprocal identity for 1 over cosine theta, that is secant theta. Okay, guys? Then minus 1. And the exponent of this is 2 also. Okay? So I applied a to the n, b to the n. That is equal to what? A, b, quantity to the n. So I will have this right side here. And then, since this is in terms of secant theta already, so I have to express this also in terms of secant. So this is 1 minus 1 over secant theta. Okay? Then quantity squared. So from which I can now have here get the LCD. No? So let's get the LCD here in the second factor. I mean in the second term. So what's the LCD? Secant. So we have now secant theta minus 1 all over secant theta. Okay? Then quantity squared. So if you have A over B and that is raised to n, I can have it A to the n over B to the n from one of the laws of exponent. Okay, guys? So this is equal to what? Sine squared theta multiplied to secant theta minus 1 quantity squared. So here, I can write this secant theta minus 1 quantity squared, and that is over secant squared theta. Okay? Yeah. So I think we're now close, no? So let me erase this now. I'm going to copy this part because I'm going to move to the next slide. Take note that what we want it to be equal to 1 minus secant theta quantity squared. So that's our goal. So what is common here? So there is a common factor or greatest common quantity in these two terms, no? What is the greatest common? So that is secant theta minus 1. Okay, a two-term expression quantity squared. So that's common. If I'm going to remove secant theta minus 1 quantity squared from the first term, so I can have sine squared theta as the remaining quantity. What about here? If I remove this as a factor, so what is left? 1 over secant squared theta. Okay, guys? Yeah. So after factoring out this quantity, then let me copy this. Secant theta minus 1 quantity squared. And this is equal to what? So copy sine squared. But 1 over secant squared theta is equal to what? Cosine squared theta. Because 1 over secant is cosine by reciprocal identity. Therefore, cosine squared theta is equal to 1 over secant squared theta. But this identity is famous, no? As famous as Galileo Galilei. Okay? What is this equal to? So that is equal to 1. So I can now cancel this, and that is equal to 1. Okay, guys? So 1 times this, I now have secant what? Secant theta minus 1 quantity squared. Okay, guys? So take note, this is what we want. Now, are they now equal? Now, from algebra, if you have a minus b and you square it, that is the same as b minus a quantity squared. Interchanging the position of the terms inside when it is raised to even power will not affect the value. Okay, guys? So it means I can write this as what? As 1 minus secant theta quantity squared. Okay, guys? So again, from your algebra, a minus b is equal to what? Quantity squared is equal to b minus a quantity squared. Interchanging the position of the terms inside, if it is raised to even, specifically raised to 2, so this is what? This is equal to b minus a quantity squared, okay? Actually, you can expand, no, to really show that they are really equal. B squared minus 2ab plus a squared. Okay? Only the terms, the arrangement of the terms uh, is the difference, na? But they are equal. Okay? So secant theta minus 1 quantity squared is the same as what? 1 minus secant theta quantity squared. Okay, so we're done. So that's what we want. So, okay? So let's have number 6. Number 5, I mean. I can now erase this. Okay, number 5. Let's see what we have for number 5. We have cosine squared theta, over 1 minus sine theta. And this is equal to 1 plus sine theta. Okay? I think this is easier to work with, no? So let's work on the right side. On the left side. Make it the right side. Okay? Cosine squared theta when expressed in terms of sine, because the right side is in terms of sine. So let's express cosine squared in terms of sine. That is equal to 1 minus what? 1 minus sine squared. Okay? So 1 minus sine squared theta all over 1 minus sine theta. And the numerator is of the form a squared minus b squared. So I can factor that in terms of a plus b, a minus b. So I have a plus sine theta times 1 minus sine theta all over 1 minus sine theta. Okay? Okay, obviously, we can cancel this out. So getting now 1 plus sine theta, which is our goal, no? So that's it. So, okay, we're done. Okay, so we have proven that the left is equal to the right.